real exam questions. This is question 26 and it deals with beam design. A reinforced concrete beam with concrete quality C3037 has a concrete strain of 0.15% and a steel strain of 1% under a load in ultimate limit state persistent. Which domain of strain diagram is this? The width of the beam is 400 millimeters and the effective depth is 652. Determine the position of the neutral axis, the resisting bending moment, and the reinforcement number and diameter. We look now at the overall picture of the strain diagrams indicating the different domains. On this axis, you will see the strain in the concrete. This is the stress in the concrete, and you have the parabola relationship up to epsilon C2, which is 2 per mil, and the rectangular relationship up till epsilon Cu2, which is 3.5 per mil. For the steel, you have here the stress in the steel, and it goes up linearly up till you reach FAD, and then it goes with a horizontal tack. In our case, we have epsilon C is equal to 0.15%, and epsilon UG was 1%. So this is this dotted line, the situation of the beam in this question. So this is region, of course, 1B, so or domain 1B. By integration, see video 11 of the playlist concrete beams, how this is done by integration. You can find what is the point of gravity of the total concrete stress, and this is 0.36 times x, with x the situation, the position of the neutral axis. And C, the filling coefficient, is for this dotted line equal to 0.5628. The most easiest way, of course, is using the concrete tables instead of doing every time the integration. So in our case, we have epsilon C is equal to 1.5 per mil. And from that on, we can see immediately that C and delta G are the values of it. We also see that we are in an area 1B where the steel is yielding. Now let's look at the cross section. We have the tension reinforcement. We ignore the compression reinforcement, and it's a beam of 400 millimeter width. This is the section before loading, and this is the section after loading. We know that this is the position of the neutral axis, and that this is 1.5 per mil, and this is a 10 per mil in the steel. It corresponds with the stress in the concrete, the compressive stress in the concrete is a portion of the parabolic relationship, and the total force in the steel with D equals to 652 millimeter. So we know that delta G, the position of the compression force in the concrete, is at the distance 0.3611x because it's in the domain 1B. We know that the filling coefficient is 0.5628, and x, of course, x is you can find with similar triangles. It is, of course, equal to 1.5 divided by the sum of those two, and times d, which is 652. So x gives you 85 millimeters. That is the position of the neutral axis. Now we will look at the bending moment, the capacity in bending. FCD, the design value of the compressive stress in the concrete, is alpha CC times FCK divided by the material factor. We are using the Belgian application document to Eurocode 2, So for us, alpha CC is 0.85. In most other countries, it's 1. So this gives us 17 megapascal. The total force in the concrete, compression force in the concrete, is then the filling coefficient times BXFCD. And we can calculate it as 325 kilonewton. We know that from the horizontal translation equilibrium that Fc must be equal to Fs. So Fs is 325 kilonewton. The lever arm Z is of course d minus delta Gx. We can put in some numbers and we find for Z 621 millimeters. So the total bending moment of resisting bending moment is lever arm times the concrete component Fc, which is 202 kilonewton meter. The reinforcement, the tension reinforcement is of course the force in the field in the rebars, which is Fs divided by the design value of the yield strength. This is because Fs is equal to Fc. That's why we can calculate the reinforcement directly, which is 747 millimeters, square millimeters. Or if you transform it into diameters, it's 5 diameters 14, which is 770, which is close enough. So what we have now as answer is that the tension reinforcement is 5 diameters 14. And we will check it now on the, if it is possible, that it is in one layer, of course. And the width 400 must be bigger than 5 times diameter 14 plus the distance between those reinforcements is at least 40 millimeters. So 4 times 40 millimeters plus 2 times the diameter of the stirrup plus 2 times the concrete cover. But there are some elements that we don't know. We don't know what is the stirrup size. We don't know what the concrete cover is. So if you work it out, then you will see you need a solution where the sum of the stirrup diameter plus concrete cover must be smaller than 85. If not, then the 5 diameters 14 cannot be put in one layer. But this is quite possible, for instance, for a diameter 12 and then a concrete cover of, let's say, a maximum of 40, it is quite possible to make it like that. So the answer is domain 1b. The position of the neutral axis is 85 millimeters. The total capacity in bending moment in ULS P is 202 kilonewton meter, and the reinforcement is 5 diameters 14.